Good morning everyone. I am Jinaresh from ECE section studying in IARA college. This is the Tech Talk PPT of Microprocessor and Microcontroller subject. My topic is about microprocessor and microcontroller and systems in the new millennium. Let's get into the topic. Moore's law and its impact. In 1965, when preparing a talk, Jordan Murray noticed that out noticed that up to that time microchip capacity has seemed to double each year. The space of change having slowed down a bit over the last few years, we have seen the definition of Moore's law change to reflect that the doubling occurs only every 18 months. Process and architectural change act to drive Moore's law for transistor count and also for performance. CPU cycle time measured in megahertz tends to track Moore's law following the same path as transistor count. Has a check to Moore's law, the expected transistor count starting from the 486 DX2 and projected for 7 years to the Intel Pentium 3 is 1.2 million into 1.67 or approximately 32 million transistors. This is within 12% of actual figures. Project this forward 10 more years to 2009 and the expected transistor count will approach 28 million into 1.61 or more than 3 billion transistors with a corresponding expected CPU speed of over 100 GHz. At the same time, current architecture are becoming more system on chip or SoC centric. This change to designs incorporating a whole system on one chip implies large number of input and outputs will need to escape from the day. Market dynamics and usage models are useful considerations when predicting the possible architecture paths for the CPUs and the systems. Currently, the driving requirements for CPU is to provide the absolute highest general purpose performance possible. The performance treadmill of a PC market drive is needed. The PC is at its core a general purpose machine and must fit the need of wide range of users from the business person to the third person shooter 3D game player. The PC's non-application specific nature requires the concept of performance headroom. The usage model for consumer device indicates that performance is more pervasive than measured. Applications require a fixed baseline amount of performance. This equates to typical browsing, word processing, reading, or waiting for input. The old paradigm of designing a system with enough headroom to handle the worst case performance requirement need refreshing. The new paradigm lets designers treat to occasional high performance requirement has an IPR and design the core architecture with this in mind. Figure describes this idea. Conflicting requirements has internet usability and personalization drive the requirement of future CPUs and system design a few fundamental cornerstones for technology and architecture will emerge. They are battery life, portability, security, connectivity for user interface, application compatibility, universal data access, and the cost. Performance and the net. The dichotomy of requirements in the CPU and system design world is the need for the base level of performance and the need to support impulse function representing high levels of performance requirements. With the exponential growth of internet and its spread to other media such as cell phones, PDAs and appliances, compute computation power is growing at almost factorial growth rates. The puzzle is how to make use of this power. Efforts are underway towards the use this interpret power. For example, the SETI Search for Extraterrestrial Intelligence project allows users to make their processor available as part of group effort to analyze satellite and radio telescope data in the search for extraterrestrial intelligence. Likewise, future microsatellite system design will provide small, lightweight, low processing modes that work in concert to solve problems requiring high processing and functional capability than any individual microsatellite can provide. Human interaction. Finally, CPU and system architecture will evolve to achieve more and better interaction with each other and with humans. At the local level, analog technological improvements will allow for CPUs for communicate directly with the nervous system to aid in medical, physical and mental improvements. At the internet mesh level, system will take on the capabilities of service or informational agents. Interpret power will allow for human-like features such as emotion, anticipation of events or results, adaptation to events, and ability to communicate users with the personal agents to aid with problems or provide advice for medical, travel, emotional investments, and many other areas. CPU, CPU, microcontroller, and the system architectures in the 21st millennium will become more flexible for the market and customer requirements. The Murray law protection of technology files against the historical model of personalization and market specific requirements of consumer products. The standardization of data, transcoding of applications, and exploitation of computation power on the internet will let users take advantage of interpret power for high performance applications. Necessity dictates change. Divergence points dictate change. Both have broad architecture to require the inventions. Thank you.